Compositions Part 2. Practice Problem 2. The graph below shows triangle ABC becoming triangle A double prime, B double prime, and C double prime under a glide reflection. That means there will be a glide and a reflection, not necessarily in that order. Write a composition of transformation representing this glide reflection. So now we're going to write the rules. How did we get from here to here, and then from here to here? Well, if we look at this one, if we folded the paper right here on this red line, we would see that the picture, or that the function, would cover each other up. So this would be a reflection, and it would be about the y-axis. So we're going to reflect across the y-axis. And then if we look what happened from A prime to A double prime, well, the x value remained the same at -4, but the y value changed from 1 to 7. So we would say that the x value stayed the same, but we went up 6 for the y value. If we looked at the B, the x value stayed the same, but the y value increased by 6. Same thing with the C. And then it asks us to write one transformation or mapping that will accomplish the same glide reflection. So how could we get from here to here with one rule, not the two? Well, first, write your ordered pairs. So A was 4, 1, B, 1, 1, C, 1, 4. And then we're skipping this step. We want to go straight to this step. So we write those ordered pairs down. A double prime is -4, 7. B double prime is -1, 7. And C double prime is -1, 10. What happened from the A values? The numbers remained the same, but it looks like it became opposite. So for our x value, we're going to call it the opposite of x. Now let's look at our y value. How did we get from 1 to 7? From 1 to 7. From 4 to 6. It looks like we added 6 to the y value. So our rule could be the opposite of x and add 6 to y. So this next one, for you to try, you can pause the video, and when you're finished, come back. It says write a composition of transformations representing this glide reflection. So we first find our original, or pre-image, A, B, C. This is the next one, A prime, B prime, C prime. And this one is A double prime, B double prime, C double prime. So if we go from here to here first, do you see that that is a reflection across the x-axis? So reflect across the x-axis. And then A came here, it went up 2, and 1, 2, 3, 4, 5, 6 right. So what are we going to add or subtract to the x value? Would that be the 2, or would that be the 6? 6. That would be the 6. So x plus 6, and then y up 2 would be plus 2. Let's see if that works for B. If B is -1, 2, if we plug it into our rule, -1 plus 6 is -5, and 2 plus 2 is 4. So -5, sorry, that's not -5, that's +5. +5 1, 2, 3, 4, 5. 1, 2, 3, 4. So yes, that is correct. To write it as one transformation, I'm going to first write my ordered pairs. -5, -2, -1, -2, and 1, 2, 3, 4, -5, 0. Now a double prime is 1, 4. Yes. B double prime is 5, 4. And C double prime is 1, 2. So what could we do to -5 to get to 1? If we add 6, does that work for this? -1 plus 6 is 5. -5 plus 6 is 1. So yes, that works if we add 6 to the x value. Check the y out. -2 to 4. Let's see. If I add 4, -2 plus 4 is 2. That's not right. If I add 6, -2 plus 6 is 4. -2 plus 6 is 4. -2 0 plus 6 is 2. That is not correct. So let's say, let's subtract 6. Or let's subtract 2. Y minus 2, -2 minus 2 is -4. Zero plus 2 is 2. -2 plus 2 . Y minus 2, -2 minus 2.